Hello, class. So, today we're going to continue looking at functions, okay? And kind of titled this section, Looking at Things as They Change. And kind of what I mean by that is what happens as the values of x change with a function, okay? So, last time we kind of went through what a function was, okay? Function is a style of relationship where we get the same outcome for any same x. So like for this number 1 here, if I plug in x equals 6, I'm going to get the same outcome for 6 every time I plug 6 in. Okay. Now I might get the same outcome for 6 as I get for say 12. That's okay. But I'm not going to plug a 6 in and get a 10 and then plug a 6 in again and get a 22. Okay. So for every x that I plug in, each one of those x's has a corresponding y value and only one corresponding y value, okay, in order to be a function. Now, with functions here, it's important to note, especially with function notation, which is what we're about to look at, how things change with the value of x you choose to plug in. Okay, so for number 1, it says f of x, and just keep in mind that f of x just stands for a function of x. Okay, so a function of x equals 7x minus 5. Now sometimes, a lot of times, we'll say y equals 7x minus 5. Okay, a lot of times we'll substitute in a y for f of x. But in this case, we're going straight with f of x. Okay, and we also know here that x in this case is going to be 6. Okay, so when they give you the function and then they give you the corresponding x value that they want you to use, what they want you to do is plug a 6 in everywhere you see an x in this function. Okay, so we're just going to rewrite this function with a 6 everywhere there's an x, and then we're going to get rid of the x. Okay, now I'm going to put the 6 in a parentheses by this 7 to indicate that we're multiplying, because that is the operation that we're doing there. But essentially, f of 6 equals 7 times 6 minus 5. Okay, we just plugged in a 6 for each of the x's in that function. So a function of 6 equals 7 times 6 minus 5. Then all we have to do is simplify. Okay, I'm not even worried about the f of 6 at this point. I'm just trying to solve the actual function itself with the numbers over here on the right hand side. So 7 times 6 is 42 minus 5. And 42 minus 5 should give us 37. So our answer here is 37. Okay, if a function of x equals 7x minus 5, and the x I decided to plug in is 6, the value that I get for that function is 37. Let's try another one. So number 2 says a function of x equals 9x plus 3, and we want to solve when x equals negative 10. So like I said, x equals negative 10 means I plug negative 10 everywhere I see an x. That's exactly what I'm going to do. Okay, so f of negative 10 equals 9 times negative 10 plus 3. Then we're just going to solve this right hand side. 9 times negative 10 is negative 90 plus 3. Negative 90 plus 3 gives us negative 87. Okay, and that is our answer. So when we plug negative 10 into this function renders a value of a negative 87. Let's continue on. Now this one says evaluate each function. F of x equals negative 8x minus 9, and we want to find f of negative 3. Now instead of saying x equals negative 3 here, they're just telling you to go ahead and plug negative 3 in for x. That's what it means by putting that negative 3 in the parentheses instead of the x in the parentheses. All we're doing is substituting this negative 3 in for the x itself. So let's do that. F of negative 3 equals negative 8 times negative 3 minus 9. Now, negative 8 times negative 3 is going to give us positive 24 minus 9. And 24 minus 9 should give us 15. So that f of negative 3 equals 15. A function of negative 3, in this case, equals 15. Next one's fairly simple. F of x equals 4x, and we want to find f of negative 15. So I just want to put negative 15 in for these x's. So I'm going to do f of negative 15 equals 4, basically, times negative 15. Okay, 4 times negative 15 is going to give us negative 60. That is our answer. So a function of negative 15 here equals negative 60. Let's get a little more complex. Now, let's take the same function, but let's change the input value of x. So here the function is f of x equals 3 times negative 2x plus 7. Okay, and that negative 2x plus 7 is in parentheses, and we want to find f of negative 7. This means that I'm plugging in negative 7 for this x and then solving. Okay, now I have to keep with my order of operations here. So I'm going to leave that 3 on the outside of the parentheses, and negative 2 times negative 7 is positive 14. So now I have positive 14 plus 7. I will evaluate that. Positive 14 plus 7 is 21. So now I have simplified it to 3 times 21. And 3 times 21 should give me 63. So this function of negative 7 is positive 63. Okay. Now let's look at what happens when we change the input variable x. In this case, we're changing it, for number 2, we're changing the input variable of x to a 13. So f of 13. Now, we're keeping the same function, but instead of plugging in a negative 7 like we did last time, we are now plugging in a 13. Okay, so I have 3 times negative 2 times 13 plus 7. I'm going to keep the 3 on the outside. Negative 2 times 13 should give us, what is that, negative 26, then plus 7. Negative 26 plus 7 is going to give us a negative 19. And can anybody tell me what 3 times negative 19 is? Ideally, you'll pause and work it out by hand just to get you a little more practice, but it should give you a negative 57. So, this function of 13 should render an output value of negative 57. Hopefully you tell this isn't supposed to be overly difficult. We're just plugging in and simplifying. And as you could tell with this function, every time I put in a new input variable, I'm getting a new output variable. Now it's not always like that. You can put in a bunch of different input variables and get the same output variable and it still be a function. But in this case, I'm getting all different values. Now let's find f of 11. Okay, so here I'm going to take this same function, 3 times negative 2, and then I'm going to plug in the 11 for x, plus 7. I'm going to have to simplify this. So negative 2 times 11 is negative 22, plus 7. Negative 22 plus 7 is going to give us, what's that, negative 15. Okay. And 3 times negative 15 is negative 45. Very nice. Now, let's do number 4. Same function. Nothing to panic about here. Same function. But here we're plugging in a negative 8. So I'm going to go 3 times negative 2 times negative 8 plus 7. Okay. Now, negative 2 times negative 8 is positive 16 plus 7. 16 plus 7 should give us, what is 16 plus 7? 23. Okay. And 23 times 3 should give us 69. Very good. So, we plugged in several different input values for this function. We got several different output values for this function. The only thing that changed here was not the function itself, but just the input variable x. All right, let's try another one. So, it says if f of x equals negative x minus 11, we want to find the following. We want to find 4 times f of negative 2 plus 5 times f of 1. Now, we can get complicated with these functions, and we can basically perform functions on functions. And that's essentially what we're doing here, is performing a function on a function. Okay? The 4 times f of negative 2 plus 5 times f of 1 is essentially a function that is using the initial function f of x equals negative x minus 11. Okay? Let's see how this works. Okay? I hope I have enough space here. Now, all we're going to do here is start with the function they give us here at number 1, 4 times. I'm going to use a parentheses to indicate times. And then here, it wants me to plug negative 2 in for x in this function. So negative 2 minus 11. Okay, but we're not done yet. I'm even going to change colors here. We have to also do this next part of the function. We have to add 5 plus f of 1, or 5 times f of 1. So we need to plug 1 now into this function for x. So it's going to be negative 1 minus 11. This is our entire new function that we have to solve for. Okay, so I'm going to go back to my original color. Alright, so let's see what we have here. See if we can simplify it down some. So, negative 2 is a positive 2. So we're going to have positive 2 minus 11 plus 5. And negative 1 and negative 11 gives me a negative 12. Okay. 2 minus 11 is going to give me, that's what, negative 9. So 4 times negative 9. Plus, or is it minus? 5 times negative 12 is actually negative 60. So, instead of using a plus here, let's use a minus. We're almost there. 4 times 9 is 36. So we're looking at negative 36 minus 60, which should render us a value of, what is that? Negative 96. And we have changed a lot from our initial function to get that value. We've taken our initial function, created a whole separate function out of our function, and done multiplication to it and inputs to it for our input variable of x. Let's see how more complicated we can get. Okay, number 2 here says 3 times f of 5 times f of 2. Okay, 3 times f of 5. That means that I want to plug in 5 into this function for x. And then I want to find f of 2 and multiply by it. Okay, so I'm going to plug 2 into the function. Okay, so the f of 2 part is represented in red. The f of 5 is represented in green here. And of course you still have the 3 out front that's also in green. Now let's simplify the whole thing. Okay, simplify the parentheses first. Negative 5 minus 11 gives us negative 16. And then negative 2 minus 11 gives us negative 13. Okay, now we just need to multiply 3 times 16 times 13. Now notice I dropped the negatives off because negative 16 times negative 13 gives us a positive number. So those two negatives cancel each other out, so we're essentially just multiplying 3 times 16 times 13. Or if you want to on your calculator, if you decide to use a calculator here and not do it by hand, you can do 3 times negative 16 times negative 13. Your calculator and your calculations by hand should give you the same thing. Should give you 624. Awesome. So we're getting a little hard here. A little difficult, but we can do it, no problem. Now the next one says negative 5 times f of 12 minus negative 2 times of f of 9. Okay. All right. So let's plug this in. Negative 5 f of 12. So negative 12 minus 11. Okay. Minus 2 times f of negative 9. So minus negative 9 minus 11. Okay, let's see if we can simplify this. This is going to, I'm going to move it a little bit, give us some space. This is going to be negative 5. Now negative 12 and negative 11, so negative 12 minus 11 should give us negative 23. Minus 2 times negative 9 gives us a positive 9. Minus 11 should give us a negative 2. Whew. A lot of stuff to go through here. A lot of little steps here. And if you need to write it out, take it a little more step by step, by all means, go ahead and do that. All right, negative 5 times negative 23 means the two negatives cancel out. And 5 times 23 is 115. So I'm looking at 115, and negative 2 and negative 2 is positive 4. So I should have 115 plus 4, which gives me 119 as my answer. If you can get through this, you're doing really, really well. Really, really well. Let us try the last one here. It has a division in it. Everybody loves division, right? So I have f of 9 divided by f of negative 6. Okay? So f of 9 is going to be negative 9 minus 11. And f of negative 6 here is going to be negative 6 minus 11. And I'm using the bar here as my division sign, but I'll highlight it in blue just in case so you know what's going on. Let's simplify it. Negative 9 minus 11 gives us a negative 20. Negative 6 turns it into a positive 6. Positive 6 minus 11 gives us negative 5. And negative 20 divided by negative 5 should give us positive 4. Very nice. Alright. Let's try the last one on this page and then get a little more complicated. What is the value of f of 4 if f of x equals negative 4 times x plus 3 minus 14? Okay. Alright, so all we're doing is substituting 4 in for x in our equation. Okay. So f of 4 here equals negative 4 times 4 plus 3 minus 14. Okay. Now, 4 plus 3 is 7. So I'm looking at negative 4 times 7 minus 14. Negative 4 times 7 is negative 28 minus 14. Okay. Negative 28 minus 14 should give us the negative 42. So our answer here should be number 3. Very nice. Now that was linear functions. Okay. We can definitely get more complicated and use polynomial functions. And all that's meant by polynomial functions is you might have an exponent on some of your x values here. Now I'm not going to do this whole worksheet. I'm going to leave some of this worksheet for you to practice. But we are going to try a few of these just so that you can get at least a taste here of the polynomial style functions. And I want you to see that they're not truly meant to be that much more difficult than the linear functions. They just require a little bit more calculation. So let's look at this first one. f of x equals 3x to the 6 plus 2x squared minus 7x plus 15. And we want to find when x equals 1, which basically means we want to plug 1 in for all of these x's. Okay, so let's find f of 1 in this case. So I'm going to do 3 times a 1 to the 6th power plus 2 times 1 squared minus 7 times 1 plus 15. Okay, now if you know your exponents here, you know 1 raised to any exponent is just going to be 1. So this is essentially just 3 times 1 plus 2 times 1 minus 7 times 1 plus 15, which is essentially 3 plus 2 minus 7 plus 15. 3 plus 2 is 5, minus 7 is negative 2, plus 15 is 13. Like I said, all that is added by a polynomial function is additional x's, and some may have exponents on them. Okay, let's look at number 2 here. Let's look at number 2. Number 2 says f of x equals x to the 5th power. And we want to solve the function when x is negative 3. So we're just going to put in negative 3 for x. Okay, so f of negative 3 equals negative 3 to the 5th power. Okay, now a negative raised to an odd power is going to stay negative. Think about it, right? Think in terms of something simple like 1. Negative 1 times negative 1 is positive 1, times negative 1 is negative 1, times negative 1 is positive 1, times negative 1 is negative 1. So that was 5 negative 1s rendered a negative 1. So 5 negative 3s is also going to render a negative. We just have to figure out what 3 raised to the 5th power is. Now, keep in mind that just all we're doing here is doing 3 times 3 times 3 times 3 times 3. Okay, so 3 times 3 is 9, times 3 is 27. So we've done it 3 times now. Times 3 is 81. Times 3 is 243. So I'm looking at negative 243. If you multiply negative 3 5 times. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3. Feel free to use a calculator on the more complicated exponents. Okay, you'll definitely have access to one in Math 108. Alright, evaluate each function. F of x equals x to the 4th minus 4x plus 10, and we want to find f of 4. Okay, so we're going to plug 4 in for all of these x's. We're looking at f of 4 equals 4 to the 4th power minus 4 times 4 plus 10. 4 to the 4th power, what is that? That's 4 times 4 times 4 times 4. That should give us 256. Negative 4 times negative 4, or sorry, negative 4 times 4 is negative 16 plus 10. Okay, 256 minus 16 gives us 240, plus 10 gives us 250. And we're done. Like I said, not meant to be hard. You just got to know where to plug in for your x, and then you just got to take your time and solve it out. Like I said, if it takes you more steps, by all means, take as many steps as you need to get to the final answer and solve it at a slower pace. Hopefully you're pausing before I even do these, plugging them in on your own and attempting to solve. Let's look at number 2. F of x equals 5 times x to the 6th power plus 3 times x to the 3rd power minus 2 times x squared minus 6, and we want to find f of negative 2. Okay, so I'm going to plug in negative 2 everywhere that there's an x. Okay, now I'm going to simplify best I can. Okay, negative 2 to the 6th power. Okay, It's going to be a positive number. So we're looking at 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. We're looking at 64. Okay, negative 2 to the 6th power is 64. Okay, now we're doing 3 times negative 2 to the 3rd power. So negative 2 times negative 2 is going to give us positive 4, times negative 2 is going to give us negative 8. And then minus 2, negative 2 squared is 4, minus 6. Okay, continue to simplify. 5 times 64 should give us 320. 3 times negative 8 is negative 24. Negative 2 times 4 is negative 8. And of course we still have that minus 6 there. And if we look at 320 minus 24, that should give us 296. Minus 8 should give us 288. Minus 6 should give us 282. Like I said, you can use a calculator to do some of those simplifications if you want to, because we are into a bigger range of numbers. Alright, I'm going to do part C, and then I'm going to leave the rest for you to try. Okay, because the rest does get a little bit more complicated. Okay, but it is very much doable based on what we did on the previous page. You just have to take a good bit of paper to work some of these out. Alright, number 1 on part C says f of 3 is what we're looking for. Our original function is f of x equals negative x to the 3rd power minus 8x squared minus 9x plus 12. Okay, we're wanting to find f of 3. So I'm going to plug 3 in everywhere I have an x here. Oh. Alright, so we're looking at negative 3 to the 3rd power. Now 3 to the 3rd power is 3 times 3, which is 9, times 3, which is 27. 3 squared is 9. Negative 9 times 3 is negative 27. And then I have that plus 12 sitting there. Okay. Alright. Continue to simplify here. Negative 27 minus 27. So 27 and 27 is negative 54. Plus 12 should give us negative 42. Okay, I just combined this term, and this term. Then I still need to do negative 8 times 9. Negative 8 times 9 is negative 72. Okay, so 42 and 72 give us negative 114. And that is the answer to number 1. Okay. Alright, I'm going to skip number 2. I'm going to go down to number 4. Okay, you can try number 2 and you can try number 3 on your own. I'm going to go down to number 4 because here we have a 0. Let's talk about what happens when we have a 0. Okay, let's plug the 0 in. So I've got negative 0 to the 3rd power minus 8 times 0 squared minus 9 times 0 plus 12. Alright. What is 0 raised to any power? Well, 0 raised to the 3rd power is 0 times 0 times 0. Well, 0 times 0 is 0 times 0 is 0. So it's just literally 0. 0 squared is also 0, and 0 times negative 8 is 0. Negative 9 times 0 is 0. So, really and truly here, just left with 12. I wanted to show you that because some people get confused when you try to do an exponent to a 0. It doesn't change anything about the 0 itself. The 0 raised to any power is still just 0. Okay. On the contrary, anything raised to the 0th power is 1. But 0 raised to any power is still just 0. Alright, hope you learned something today. Like I said, go on and try number 2 and number 3. And if you want to try D and E, go for it. You should definitely be able to do E, no problem. Functions. We're going to get more into them. But now we can plug input values into function and find output values. Regardless of how those input values change, we can still plug them in and find the corresponding output value. Okay, the basic part of being able to plug into a function, very important. So, if you have any questions, reach out to me. Other than that, I'll see you next time.